All right, so now we move into the math portion. And I had a quote, a sound bite on there, you know, when I had all the sound hooked up at one point from Fletch. You know, I was told there would be no math. This is, the math portion is for the purpose of electing our delegates to the county assembly. And this is where people start to glaze over, their eyes kind of get heavy. Oh, I hate math. But you got to do some math. There's a couple of keys to remember. Number one, if a candidate, regardless of how many people you have there, regardless of how many delegates you have to elect, if a candidate doesn't get 15% of the votes, they don't get any delegates, period. Period. And the other key point to remember is that there is a third candidate besides Bennett and Romanoff, and his name is undecided. Her name is undecided. Undecided is a candidate choice. You treat undecided just like any other candidate, or uncommitted. I think actually, I don't know why I have undecided, because technically the term is uncommitted. So if uncommitted gets 15% of the vote, uncommitted gets delegates. If uncommitted gets 10% of the vote, they don't get any delegates, just like any other candidate. So this is kind of what the math worksheet looks like. And I think it looks actually is a little more simpler this year, because they don't have you necessarily worry about what the threshold is, because they have a table for that. But let's say we have 3 candidates, or 2 candidates for office, and then we have uncommitted. So this is what your caucus night spreadsheet will look similar to. And let's say you have 5 delegates for precinct 387. 5 delegates you have to figure out how to divide. So you take your vote, and John, and this is whether you do a straw poll or not, this is the actual vote. And in your vote, John Smith gets 9 delegates, Jane Jones gets 9 votes, Jane Jones gets 4 votes, and then 2 people vote for uncommitted. Okay? So you have 9 plus 4 is 13. You have 15 people voting at your precinct caucus. So the next thing you do is figure out what the threshold is. Now, you've got this math down here, but quite frankly, up in the top corner of your sheet this year, you have a little cheat sheet. And it'll tell you if you have 15 delegates, the threshold is X. In this case, the threshold is 3. So you just look up here in the corner that doesn't exist, and that'll tell you what your threshold is. If for some reason you don't have that, or you're using an older sheet, it's easy. Take 15 times 0.15. That's 15 times 15%, 15 being the total number of votes, and that number is 2.25. Always round decimal points, in this instance, up to get to that threshold. And that's why the threshold is 3, because you can never have someone voting 0.25 of the time. All right, so the next column is called votes for a viable preference. In this case, because the threshold is 3, uncommitted is not viable. Uncommitted is not a viable preference. So you just transfer over the numbers from the candidates who did get that viable preference, and you transfer over a 0 for the candidates who didn't get a viable preference. And uncommitted, because they didn't meet viability, you can fill it all the way out to the end, and you know they have 0 delegates to elect. Okay? So now we're just dealing with John Smith and Jane Jones. And we have to add up the total number of votes for just the candidates who were viable. In this case, we ignore these 2. That's why we have this column. So 9 plus 4 is 13. So the total votes for a viable preference in both of these will be 13. It'll be all the same all the way down. Okay? Everybody following so far? Yes?
Yeah, sorry, the 5s in the third column, what is that?
That's the number of delegates you have for this particular imaginary precinct. Different precincts, those are the number of delegates you're electing total to the county assembly. So the next thing you do, this is where it gets messy, is you do each candidate to figure out what their raw number is. For John Smith, they have 9 votes out of 13 votes. That's 69%. They have 69% of the votes. So that's 0.69. Then you take 69% times the total number of delegates, 5. So if you had hundredths of a delegate, they would get 3.45 delegates. Okay? And then Jane Jones, you do the same thing. 4 out of 13, 4 divided by 13 is 30.8%. I must have rounded the number up here. 30.8%. 30.8% times 5 is 1.54 delegates. So again, if you have hundredths of a delegate, we're done. The problem is counties don't really elect delegates by the hundredths. So this is where we figure out who gets what. And we look to the number to the right of the decimal point, or you can do basic rounding, and because of the number of candidates involved. If you had, I think it's either 5 or 6 candidates or more, you really can't round. But because you have 3 candidates, rounding generally works. In any event, you take the higher number on the right side of the decimal point, and that's who gets the extra delegate. So 3, 1. You got to figure out where that's 4 delegates. You got to figure out where the 5th delegate goes, and that goes to the candidate that has the higher. What's the mathematical term? Remainder product? I don't know. Higher decimal points. And because that has, Jane Jones has a higher decimal points, she'll get the extra delegate. So then you know you have 3 delegates to elect for John Smith, 2 for Jane Jones.
Okay. What if you had 3.45 and a 1.54? Suppose you had a 0.94 at the bottom.
Down.
You know, the third person.
Right.
Let's just say qualified enough to where you can get a 0.94. Now, how would that be handled?
The 0.94 is higher than the 0.54 and the 0.45, so then 0.94 would get the extra delegate.
Okay, so they would get a delegate, and then you go to the 0.54 if there's another delegate.
Exactly, yes.
Okay.
Although, again, I think mathematically that's not particularly possible in this instance because of the 3 candidates. You couldn't. I don't think it's possible to have 3 candidates, even if all 3 meet threshold. I'm not sure it's mathematically possible to have 2 candidates over 0.5. I'm not sure, but I could be totally wrong. I'm not sure that it is. All right. One other point I think I don't have on here. There's a tie. If there is a tie, in other words, you could have both candidates end up with 0.5 as their decimal point. So you get 3.5 and 1.5. Or you could end up with all 3 candidates with 0.33333 as their decimal point. In the case of the 0.5, for the extra delegate, you have a choice, and I think the state is now, and I think both the campaigns have, I think, agreed that you're going to elect half delegates. So each campaign will get a half delegate. If that's not the case, the other option is just to draw straws or flip a coin or whatever. If you have a 3-way tie, you can't have a third of a delegate. We allow for half delegates. We don't allow for thirds of a delegate. If that were to happen, then I think you do have to draw straws to figure out who gets the, if there's 1 delegate to give out, who gets that 1 delegate. Except, if you have 2 candidates that already have delegates and the 3rd candidate has no delegates, that 3rd candidate is entitled to a delegate. You can't have someone who meets the threshold not end up with anything. Okay? Most of this you won't even have to worry about because it will be a lot simpler when you actually get into practice. Any questions on the math? Because I'm done with the math. Yes?
Will that math form be on our worksheet that we will have that night?
Yes. That worksheet should, that's actually the worksheet you'll have.
All right.
That's the form that you'll have.
It'll tell us in here then what steps to take.
It should, yes.
Okay.
Yes. It should, and the rules should as well.